Welcome to another video in our Coding with Arduino for Young Innovators. In the previous class, we discussed the various electronic components we will use to build our first electronic circuit. In this class, we are going to use those components to build that circuit and see it work in real life. So, let's get started. Before we build the circuit, let's quickly look at how these components are represented in circuit diagrams. In electronics, we use symbols to represent components. This is a battery, and these are the symbols we can use to represent a battery. This is an LED or light emitting diode, and this is the symbol of a light emitting diode. This is a resistor, and these are symbols we can use to represent a resistor. This is a switch, and this is the symbol of a switch. This drawing is called a circuit diagram, also known as a circuit schematic. A circuit diagram shows how electronic components are connected using their symbols. Here, you can see the battery connected to the switch connected to the resistor connected to the LED connects back to the battery, forming a complete circuit. Right now, the circuit is open, as you can see here, because the switch is not closed. This switch here is not closed. Since the circuit is open, electricity cannot flow through the switch. For electricity to flow from the battery and around the circuit, the switch must be closed. Once the switch is closed, the circuit becomes a closed circuit and electricity can flow. Remember what we discussed in the previous lesson about open circuits and closed circuits. If you have forgotten, you can revisit the previous video and refresh your memory. Now that we have seen the circuit diagram, let's build the real circuit. Here are our components: the battery, the light emitting diode or LED, a resistor, a switch. We will also use a breadboard and some jumper wires to make the connections. So here we'll have the breadboard, some jumper wires, a battery, a light emitting diode, a switch, and a resistor. Now let's build our circuit. Let's make our first project. To make the circuit, I will first connect the battery to the breadboard using a battery cap. So here is my battery. I will connect it to the breadboard using this. This is called the battery cap. It helps us to connect the battery to a breadboard. So I'll connect the battery to the battery cap. Now that I have connected the battery to the battery cap, I will connect the red wire of the battery, which is the positive terminal, to this hole of the breadboard. So I can connect it here, and I will connect the black wire, which is the negative terminal, to this hole. It means that anything I connect on this line will be connected to the positive terminal of the battery, and anything I connect on this line will be connected to the negative terminal of the battery. So the next thing I will connect is the switch. I will connect the switch to the battery the same way we have it in our circuit diagram. So I will connect one leg of the switch to the positive leg of the battery, or the positive terminal of the battery. This is the positive terminal of the battery. It is connected on this line of the breadboard. So I'll connect one leg of the switch here and one leg of the switch anywhere else on the breadboard. So you can see that I've connected one leg of the switch here and the other leg of the switch here. Then I will connect the resistor. I will connect the resistor exactly the same way it is connected on the circuit diagram. So I will connect one leg of the resistor to one leg of the switch, which is this leg, and I will connect the second leg of the resistor to any point on the breadboard that is not where the battery or the other leg of the switch is connected. So I can connect my other leg of the resistor here. So now we have the resistor connected, the switch connected, the battery connected. Having connected the resistor to the circuit, the next component I will connect is the light emitting diode. I will connect the positive terminal or positive leg of the light emitting diode or LED to the second leg of the resistor that is not connected to the switch. And that leg is this leg. Now, to identify the positive leg or positive terminal of the light emitting diode, I will look at the light emitting diode legs and identify the longer leg. The longer leg is the positive, while the shorter leg is the negative. So I will connect the longer leg, which is the positive leg of the LED, to this leg of the resistor, and the other leg of the LED I'll connect anywhere on the breadboard. So here I have the positive leg of the LED connected to this resistor leg, and the other leg of the LED is connected here on the breadboard. So far I've connected my battery to the breadboard, and I connected the switch to the battery, and then I connected the resistor to the switch and the LED to the resistor. To make the circuit complete, I need to connect the negative leg of the LED back to the battery. To do that, I can use a jumper wire to make the connection. So I will use this male to male jumper wire to connect the negative leg of the LED, which is connected to this point, and then to the negative leg of the battery, which is on this line. So I can connect it here. Now our circuit is complete. On our circuit, we have the battery connected to the switch with the help of a battery cap. So the positive leg of the battery, which is this red wire, is connected to one leg of the switch, which is this leg of the switch, and the other leg of the switch is connected to one leg of the resistor. So this is the second leg of the switch. It is connected to one leg of the resistor, and the two of them are connected on this line of the breadboard. Anything connected on this line will make contact with these two legs of these two components. Then we have the other leg of the resistor connected on another point on the breadboard, which is this line on the breadboard. And on that same line, we connected the positive leg of the LED, which is the longer leg of the LED. And then we connected the shorter leg of the LED on another line of the breadboard, which is here. And on this same line, we connected a jumper wire looping back to the negative leg of the battery. So here you can see that we have made a complete circuit, and this circuit is exactly a replica, a practical physical replica of what we have as our circuit diagram. Our circuit diagram shows that the positive leg of the battery is connected to one leg of the switch, and the other leg of the switch is connected to one leg of the resistor, and the other leg of the resistor is connected to the positive leg of the LED, and the negative leg of the LED through a jumper wire is connected to the negative leg of the battery, making a complete circuit. However, this circuit constitutes an open circuit, and because it is an open circuit, no current will flow in the circuit. But the moment we close the circuit with the help of the switch, electricity or current will then flow from the battery around the circuit. And once that happens, our LED will come on. So let's test our circuit. If everything has been connected correctly, the LED should turn on when I press the switch. Let's count down together before I'll press the switch. 3, 2, 1, 0. Excellent. The LED is now on. Since this is a push on and push off switch, pressing it again will turn the LED off. Let's try it. So I will push it again, and you can see that the LED is off. If I do it again, it will come on, and if I push it again, it will go off. Again, on, off, on, off. We can repeat this again and again, and the circuit will continue to work as expected. If you are following along with your electronics kit, pause the video now and see if you can build the same circuit by yourself. Did it work? If yes, congratulations. If not, don't worry. Even engineers sometimes make mistakes when building circuits. Finding and fixing problems in a circuit is called troubleshooting. You can troubleshoot your circuit by checking if the component legs are inserted in the correct holes. For example, let's say you made the mistake of connecting this jumper wire here instead of here. So if we connect the jumper wire here now and I press the switch, you can see that the LED did not come on. This is because our connection is wrong. So when you make your circuit and you discover that it is not working as expected, you will go ahead and troubleshoot it. And one of the things you can do is to check if the component legs are inserted in the correct holes. So to fix this kind of problem now, what I would do is to move this jumper wire here and put it here. And you can see that because the switch was turned on, the moment I plugged the jumper wire into the appropriate hole of the breadboard, the LED came on. To turn it off, I'll press the switch again, and to turn it on, I'll press the switch. Another thing you can do is to check the polarity of the battery and the LED. So if you made the mistake of connecting the battery in such a way that you place the red wire, which is the positive leg of the battery here, and then you placed the negative here, when you press the switch, the LED will not come on. To correct this mistake, what you would do is to revert back to what we had earlier, which is to move this red wire to this point, and then you move the black one to this point. If you do that and you press the switch, you can see that the LED is on again. Another thing that can be a mistake is if you make the mistake of connecting the LED wrongly. Remember that the LED and the battery are polarized, that is, they have positive and negative terminals. And because they have positive and negative terminals, if you connect them wrongly in a circuit, the circuit will not work. So if instead of having the circuit this way, whereby the LED has its positive leg connected here and the negative leg connected here, if you reverse it and you have it this way, then if you press the switch, the LED will not come on. So this can also be a mistake you might make when making your connection that could have made your circuit not work as expected. So to correct it, you will make sure that you connect the LED the correct way. To correct this mistake now, what I will do is to reverse the connection. So I will turn the LED and connect it the appropriate way. And when I do that, you can see that because the switch was on before, the moment I reversed the LED connection, the LED came on. This is also what we can do to fix the problem why your circuit is not working as expected. Another thing you can do to ascertain whether it can fix your circuit not working is to change the jumper wire. So if the jumper wire you are using is broken inside, it means that current will not return to the battery when you press the switch. It means that that broken wire, it means that that broken jumper wire will create an open circuit in your design. If that is the case, electricity will not see a complete path to flow in the circuit. And if that is the case, your LED will not come on when you press the switch. To fix that problem, what you will do is to get another jumper wire and reconnect in the circuit and test if it will work. So if you change to another jumper wire that is okay, if you press the switch, if the problem is the jumper wire, then your LED should come on. Now, the last thing you may do to solve the problem is to change the LED. If you have changed the jumper wire and you check the LED is connected appropriately, you check that the polarity of the battery is okay, you checked and confirmed that the legs of the components are inserted in the correct holes, then what you may do is to change the LED, because sometimes you may have a faulty LED in the circuit, and if the LED is faulty, it will not work. For example, here I have a faulty LED. Let me connect it in the circuit the appropriate way. So I will connect this LED and I will connect the jumper wire. When I press the switch, the LED did not come on, though I connected it the right way. This is the positive leg and this is the negative leg, and I connected it in the circuit, and you can see that the LED is faulty. So to solve this problem, what I will do is I will change to another LED. So I will replace that LED with another one, and if I do the replacement with a good LED and I press my switch, you can see that the LED is on. So these are the things you can do to troubleshoot your circuit, to find out what the problem is, fix it, and then have your circuit working as expected. If you were able to get the LED to turn on and turn off using the switch, congratulations. Once again, you have successfully built your very first electronic circuit. Great job. Let's quickly review what we learned today. We learned how electronic symbols represent components, what a circuit diagram is, the difference between an open circuit and a closed circuit, how to build a simple electronic circuit, and how to troubleshoot a circuit when it does not work. In the next class, we will use the Arduino microcontroller and coding to build a similar circuit. That is where we will begin combining electronics with computer programming. Alright, that is all we have for this class. I am Instructor Izu, and I will see you in the next class. Bye.